In today's lesson, we'll be learning about rate of change and initial value with a focus on table of values. In our first example, we have a situation where the more you work, the more money you make. The column on the left represents our values of x, and the column on the right represents our values of y. The initial value in the situation would be $0, since you make $0 when you work 0 hours. However, finding the rate of change is a little bit more tricky. You'll notice that the earnings are increasing by 30. Meanwhile, the time is increasing by 2. Many of you would say the rate of change is an increase of $30 for every 2 hours. This wouldn't be the most correct statement, however. Now, why would an increase of $30 for every 2 hours not be the most correct statement? Well, simply put, no one cares about how much money you make for every 2 hours. You want to know how much money you make for every 1 hour. Therefore, using mental math, you could find that you make $15 for every 1 hour. Therefore, a more accurate rate of change would be an increase of $15 for every 1 hour. The information we saw in the table of values can also be represented with an equation, y equals rate of change multiplied by x plus initial value. We just determined the rate of change to be an increase of $15 for every 1 hour. Now, 15 over 1 is the same thing as 15 divided by 1, which is the same thing as 15. Therefore, the rate of change simplifies to just 15. Meanwhile, the initial value was $0, since that is how much money you make if you work 0 hours. I'm going to put 0 as the initial value. Therefore, this situation can be represented with the equation y equals 15x plus 0, where y represents your earnings and x represents your time. In our second example, we have a situation where as your distance from a basketball net increases, your field goal percentage, in other words, your accuracy, is going to decrease. The column on the left represents your values of x, and your columns on the right represent your values of y. The initial value in this situation would be 100%, since that is your field goal percentage when your distance from the net is 0. In other words, you are going to be at a layup distance. However, determining the rate of change is going to be a little bit more tricky. You'll notice the field goal percentage is decreasing by 30 each time. Meanwhile, your distance from the net is increasing by 3 each time. Now, many of you may say that the rate of change is a decrease of 30% for every 3 feet. However, this wouldn't be the most accurate statement. So why is a decrease of 30% for every 3 feet not the most accurate way to describe the rate of change? Well, simply put, no one cares about how much your field goal percentage is decreasing for every 3 feet from the net. What would be more useful would be how much it decreases for every 1 foot. Now, using mental math, you could figure out that your field goal percentage is actually decreasing by 10% for every 1 foot. Therefore, the rate of change would be a decrease of 10% for every 1 foot. The information in the table can also be represented with an equation, y equals rate of change multiplied by x plus initial value. We just determined the rate of change to be a decrease of 10% for every 1 foot. However, negative 10 over 1 is the same thing as negative 10 divided by 1, which is the same thing as negative 10. Therefore, the rate of change can simplify to just negative 10. We also determined the initial value to be 100%, since that was your field goal percentage when you were 0 feet from the net. Therefore, I'm going to write 100 as the initial value. Therefore, this situation can be represented with the equation y equals negative 10x plus 100, where y represents your field goal percentage and x represents your distance from the net.